Welcome to Pavitra Laptop Care, Mr. Param.
Welcome, sir.
See, we already discussed about basic principle of I/O requirement. Okay, but through schematic we can check what are the requirements and how we can find out what are the basic requirements and all. Okay, this is the I/O. Okay, first step, input. Right, input voltages. Okay, input voltages, what are there? First we will check the input voltages of I/O. See here, plus 3 VLP. Okay, this one coming from step down AC. Okay, this is the input to I/O. This is the first basic input. So see, this particular voltage goes to 9, 22, 33, 96, 111, 125 and 67 pins. This one is EC VCCA. This also on 3.3 volts will come, and here also 3.3 volts will be there. Once we check the input voltage, it's a plus point. Okay, this is the second minus also we have to check. That also very important thing. If one pin not connected to the ground, so one circuit loop won't be complete. So that's the reason we need to check that ground point also. Okay, here grounds are connected 11, 24, 35, 94, 113, and this one is analog ground. Okay, EC analog ground. So this is the first point. Next, second point AC in. Okay, AC in schematic. What is the AC in? First we'll check. Okay, see here it's in the name of EC AC in. This is the second point we need to check. From where it's coming? It's pin number 110. It's actually input from other circuit. Okay. So EC AC in we will copy, or directly here we will type EC underscore AC in. Okay. Here see, here AC in, it's becoming a EC and EC AC in name. Okay, see now we have to search AC in, from where it's coming. Next AC in, not this one, yes, AC in. This is the output of this particular IC. Which IC? It's a BQ24725. This is charging IC. Okay, because it's connected to CLR, so it producing AC OK signal. If AC OK adapter is valid, then AC OK will be present. So this will be 3.3 volts. Okay, this one directly connected to I/O. It comes to these solar pages. Okay. Yes, total 3 pages we have to search. See, 1549 like that. Here AC in. Next, third one, ID signal. Okay, in Dell it will be what? PSID. Okay, PSID. In HP, AD ID. These are general name I am telling you. So once we check the particular schematic, we come to know what is the name. Okay, in one schematic that name will be depends on laptop models. Now this one is HP. Okay, what we are searching the schematic, that is HP. So here ADP ID we have to search, or AD ID we have to search. See, ADP ID. Pin number 75. It's an input to the I/O. Okay, input to the I/O sense, from where it's coming, first we need to check. It's a copy, and here paste. See, this is the adapter ID. It's directly coming to the particular pin number 6 of DC jack. Okay, this is DC jack pin. This is ESD protection device. Okay, diode. Here it's connected. Here main supply and this one adapter signal both connected. and here is the output through 10k ohms resistor. This one directly connected to the IO. Okay. Next, what we have to search, after this we need to check BIOS. Okay, that also very important thing. So next point is fourth one, BIOS. There are two kind of BIOS will be there. One is main BIOS and other one is EC BIOS. Okay, here for IO EC BIOS is most important. It's required. It may be inbuilt, okay, or it may be outside IC, BIOS IC. See, it may contain directly, we have to program the IO, or like one IC will be there, that is called BIOS IC. Like that, one more BIOS IC will be there, that's for EC. That also one programmable device. This particular schematic, what is this? What is the name of this particular IO? See, it's a KB9022. It's a inbuilt. It has inbuilt BIOS IC. Okay, so we need to program it. It's called a programmable IO. In some conditions, in some IOs, non-programmable. Those list I will give you later. Okay, and next, ECN. Once supply comes, this one will start. Okay, some cases. Okay, this also very important thing we need to check. So this point goes to number 3. Okay, anyway, so next one, lid switch is checked, right? Next one is lid switch. Okay, this also very important. Here 3.3 voltage should be there, otherwise board will be in dead condition. Okay, if lid switch is on, so board will be in sleeping mode. Lid switch. Next, let's switch over. Next is on and off. Sometimes power button also they will give. Okay, this is the most important thing, power button, on and off. See, these all are requirement before pressing power button. Okay, these points should be noted down before pressing the power button. If these all available, then only it will start its work. When we press the power button, then some voltage will start. So according to that, your board will get on. Okay, this is not meaning once IO is good, then board will get start. Not like that. So what are the minimum requirement it requires? Those things we need to check. Once IO is correct, then we need to check some other parts, I mean other sections. Okay, see, now input voltage. Once input voltage comes here, first we need to check plus volts and negative means ground. Both pins are very important things. If one ground is missing, then the circuit won't be complete, then you won't get this kind of signals. This is very important. So after that, EC on by default it will start. Okay, automatically it will start. Next, AC in. This also very important thing. From charging IC you will get this signal. AC OK. AC OK, minimum 3.3 volts will be there. AC in, AC OK both are same. AC OK, actually it's IC name, IC particular pin name. After that it goes to somewhere, no, by name of AC in, it's going to IO or some other section. Okay, here EC AC in, that name is EC AC in this particular schematic. So next, this one ID, here ID. Okay, ID in Dell one name, HP one name, Lenovo also one name. Okay, according to the schematic we need to check. Now we are checking HP schematic, so that's the reason here we are getting ADPI 0.6 to 1.3 or 1.5. So depends on adapter. Okay, so adapter information over, ID information also over. Next we need to install the BIOS. bias, two types will be there, one is main and one is EC bias for IO. Okay, this one may be sometimes inbuilt or sometimes maybe external device through external IC, bias IC. So if it is inbuilt, we call it as a programmable IO. In case of outside, it's a normal bias. It will be around 1 MB, but inbuilt it will be by default 128 to 256 KB. Yeah, in KB it will be there. Okay, so bias also important. And next, EC on. EC on I already explained you. Once it gets input, it automatically starts EC on. If EC on is not generating, then we consider it as a IO has faulty, because it's a very first voltage generated from IC. This is our first output IC. Okay, if this one is good, then all function will be good. Okay, and next one is lid switch. Lid switch should be 3.3 volts. It should be in disable mode. If there is no voltage, it gets enabled and board will be in dead condition, sleep mode. What are the input you give all over the board, so then also no use. Okay, next one is on and off. This is very important thing. So here in on and off button, one is positive volts, means it's a 3.3 or 3 volts or 2.9 volts. Sometimes it may be 28 volts also. When you press, it becomes 3.3 volts. That also one logic will be there, that I'll explain you in future. Okay, this positive voltage should be there in on and off button. This also we have to check. In lid switch, on and off, it's together will be there. That we need to check thoroughly. This is the condition of before power button. Okay, now let us check after pressing power button. Here one more important point. It's a 8th one. If this particular IO fulfilled all particular voltages, then it produces RSM RST. RST. Okay, hash. Yeah, this one sometimes before pressing power button also you will get, and after pressing power button also you will get. So we are considering both condition. Okay, this also you have to keep it in your mind. This one is high low high logic, means here already 3.3 voltage will be there. Okay, when you press the power button, then it will be 0, and if you release, so again it will be high 3.3 volts. So it means it's indicating a signal, so it's ready. So please move on, please proceed, like that. That is the indication it gives to some other section, maybe PCH or some other controller I say. Okay, here see once again summary I will tell you. These are the input voltage of IO. Basic, very basic things we need to check in IO before pressing power button. Right? Understood? Okay. Next, after pressing power button. See, I told you before pressing power button, what is the last one? RSM RST. That may be before pressing power button, or maybe after pressing power button also. So this will be first point, RSM RST. Okay, hash in the sense, if it is a 3.3 voltage is there, then it's a disable mode. If it is a 0 volts, then it's a enable mode. Okay, reset in the sense it's only one time it will happen. Just reset. That's why it's a power on button given here. Button in the sense just press and release. That is the indication. Oh, I am relaxed, so I am ready to work. That is only one time it will happen. Okay, that is called RSM RST. Next, second one is like this RSM RST. One EC RST also is there. EC RST. That also same concept. Okay, 3.30. It should be 3.3. It means it's a disable mode. Here it's a enable mode. Okay. So here in IO, what will happen? No, it has multiple pins. For any one input, it gives a return output. IO function is one input output controller. Okay, it's called embedded controller also. Okay. See here, RSM RST okay, EC RST okay. Next third one power button you press it, right? Power button. Then power button out also will be there. First I told you RSM RST, right? ECRST is there. RSM RST, ECRST. This is the main RST one. And one more RSM RST I told you. That is here ECKB RST. This one is ECKB RST. That also you have to check. Okay. ECKB RST keyboard. And here I told you RSM RST. This one is, it should be output. See, this is the output. Next, which one? Power button out I told you, right? So here on and off is there, 114 pin number, and out also should be there, right? So here, see, power button out, 1 and 2, 1 to 2. This also should be there. This directly goes to where? PCH. Let me check. See here in voltage sequence, here also it's mentioned on and off, high low high sequence. After that ECRST will generate, and next power button out. Okay, these all are after pressing power button. See, power button out. See, up to here it came, power button out. Just a minute. From here, this name is power management controller power button. In this name you have to search. Then you come to know where exactly it's going. See, this is actually SOC. Means PCH. It's directly going to PCH. Now understood, right? So it's from IO, its output directly going to the chipset, main chipset. See, once it generates RSM RST or ECRST and power button out, these particular signals goes to the PCH. Then PCH will think, oh, IO is ready to work. Okay, it's giving some signals. Then I will give some other work. It will pass some other signal to IO. Those signals now it will start. So see now, bidirectional. These all are input output concept. Once it gives input, then it produces some other outputs. Then again it requires input, and again it will produce the output. Okay. Now again we will go to IO. Now I told you directly what is it, RSM RST and power button out directly going to the PCH. Okay, you want to check this particular signal also, we can check. Okay, ECRST RSM RST will copy and just you check where it's going. See, after pressing power button, ECRSM RST will generate. Okay, see, this one is SOC. ECRSM RST directly going to the SOC. Okay, so here it's confirmed RSM RST and power button out directly going to the PCH. Then PCH will decide what are the signal it has to give. Once signal goes to SOC, it will tell, so I am also ready, I also give some signal, command signal. Then according to that it will give two more signals. PCH will give two more signal. Okay, one is SLP underscore S5 or S4. Okay, first this signal, after some time, some milliseconds or microseconds, whatever it may be, second one SLP S3 or SUSP. Okay, general name I have given here. In according to the schematic, name will differ. In this particular schematic, let us check what is the name. See, this is SUSP, which I told you now. So before this, one more signal will start. What is that? See, ECSLP S4, SLP S4 and SLP S3, second one. SLP S3. SLP S3 from where it's coming? See, check here. See here, EC SLP S3. Okay, understood? These are from PCH or SOC. This is called controller main IC, main chipset IC. Okay. Now, once these two input goes to the IO, okay, then according to this, two more signal will generate IO. Okay, what are those? See, these two coming from PCH, then IO will generate two more signals. One is main on, okay, second one is susp. See here, susp ash, main on, or one more name will be there, that we will check. Okay, main on and susp, I guess. Okay, so just check. Susp one is there, and here one more signal, syson. Yes, syson, and here main on or syson. Okay, syson and susp in this particular schematic. We need to find out because multiple pins are there. No, it's a little bit tough initial times, and later it will be easy for you. So 104. Where is that? Where is that? 6 yes. Syson. See here it is there. Okay. Other two signals coming from IO, and it gives to RAM IC or some other section it gives. It depends on according to the working function. Okay. So these are general concept of IO. In deeply this one using the schematic, I am telling you how to find out in a schematic. In one schematic I am showing you. In later on multiple schematic according to the board I will show you. Okay, this is from compile. Okay, compile. There will be different IOs. So according to the schematic, what will be the input and what will be the name, next time I'll show you. Now once again I'll repeat IO requirement, basic principles of IO requirement. One is input, and second, in input what we have to check, it's the 3 volts and analog volts also we have to check, and then according to that ground also we have to check, analog ground and normal ground. Okay, after input it second option, I mean it directly generates EC on. Okay, this also we have to check. This directly goes to some step down IC input, I think so, it's enable signal. Next one, AC in adapter. Once we connect the adapter, it's very important adapter is properly connected or not. That particular IC, what is that, power IC, I mean a charging IC will give the information to the IO. So here power adapter is good, so then you can proceed on. Okay, so that's called AC in, that also very important. And next it's ID in the sense adapter ID, it's 45 watt or 65 watt or 90 watt, it's 130 watt, so many wattage will be there. That wattage adapter information goes to the IO through this ID. Okay, next is bias. Bias is 100% required. So sometimes it will combine with the main bias and it will take. Okay, sometimes it will be separate IC, that bias IC chip will be there, that one through that bias IC this bias will come to IO. And third, in third condition, inbuilt bias will be there. Some ICs IO will be programmable IO. Okay, it means by itself it will program. I mean not itself, we have to give. It's by itself it is a programmer IO. That particular program files we have to write. Okay, then only that function will start. Next, after bias we need to check lead switch. So lead always voltage should be there. It's a 3.3 minimum. Okay, maximum also that one. and on and off. In on and off button, one is ground and other one is voltage will be there. That's a 3VL voltage will comes. Sometimes always voltage will come. So depends. Okay. This basic input requirement we have to check for I/O before pressing power button, and after pressing power button. See here one more option is there. One particular pin. Sometimes before power button also it's available and after power button also available. That's called RSM RST. That may be EC RSM RST or SM RSM RST. Name will be differ, but concept will be same. See, after pressing power button, RSM RST 3.3 volts, EC RST 3.3 volts, and power button out will generate after this EC RST and RSM RST. And next PCH will give two signals. See, this alarm goes to PCH and PCH gives two signal SLP S5 and SLP S3, and next here if PCH gives these signals, then IO will generate two more signals, that is the main on or sys on and next susp. Okay, if these voltages are available, these pins are good, then it will start automatically working, that IO. Okay, it produces some particular signals or voltage, whatever it may be, according to the IC requirement or processor requirement or PCS requirement. Okay, if this is not working properly, then motherboard considering as a dead condition. Okay, we'll close this one. Thank you.